Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we are getting some awesomeness, and we are talking about logarithmic functions. Logarithms, my friends, are the inverses of exponents. That's literally what's going on here. That's why we learned about inverses to begin with. Remember, we switched the x with the y and vice versa. Well, this is what's happening with a logarithm.
Teachers, please pardon this interruption. At this time, would you please release the water?
So, basically, logarithm is just a different way to write an exponent. It's the inverse, to be exact. And what is a logarithm function? Okay, let me explain this. Y equals log of base b of x if and only if b to the y power equals x, where b is not 1 and it has to be greater than 0. What did I just say? Let me explain it right here. When you have a log, you're going to have log, and there's going to be a little value, a sub-value it's called. It's on the bottom. It's kind of an opposite of an exponent. It's at the bottom. It's called a sub-value. That is the base of the exponential function that you're dealing with. X is the answer to the exponential problem that you're given. And y is the exponent. So, when you are reading this, what this is really telling you is, hey, dude, b to the y power equals x. That's literally log. People look at this and they're like, oh my God, it's so crazy. It's not that bad. It's not that bad at all, as long as you understand how to read it. Log bx equals y is read. Log base b of x. Okay? I like to read it a little bit differently. I like to read it log base b to the power of y, to the y power, equals x, because it's b to the y power equals x. But this is technically read log base b of x equals y. You had a question, my brother. No, log is just, like I said, a fancy way of writing an exponent. Log indicates that it's an inverse of an exponent. That's literally what it indicates. Thank you, my brother. Now, as far as log goes, there are two types of logs, two main types of logs. There are infinite number of logs, but there are two types of main logs. There's something called the common log. Common logarithm, okay, has a base of 10 and will be written as log base 10 of x or just straight up log of x. When you do not have a base, when the base is invisible, please remember that that is a base of 10. When you just have log of a value, please remember that the base of that log is 10. Kind of like a square root. Isn't there an invisible 2 there? Okay, same thing here, my brothers. If I just see log straight up like that, it's log base 10. I promise. The other type of main category of log is called the natural log. And that has a base of e. E we spoke about very briefly. E is Euler's number. Euler's number roughly is 2.72. It is a value used to calculate curves and exponential functions and logarithmic functions. He basically was a really bored dude who came up with this number that helped things out. Okay, not trying to be funny about it, but that's what E is. It's not capital E, it's lowercase e, and it is in any scientific calculator. On the calculator, you'll probably see it like that, and it'll have to an x, because you could have e to the first power, to the 20th, or to the 2.5. So when your base is e, You could literally write this as log base e of x, or the proper way, ln of x. When you see ln, you know that that's a log with a base e. So if you just see log by itself, base 10. You see ln, that's a log of base e. Now, like I said to you before, guys, exponential functions and logarithmic functions are inverses. They are inverses. Okay? And this is wrong. I'm sorry. This should be an x here. I'm a fool. And that should be a y. Sorry. Right? Because think about it. It equals x, but in this one, the inverse, the x is the answer. Right? Here, the y is the power, but in here, it's the answer. So they are inverses of each other. Again, how are they inverses? Log base b of x equals y turns into b to the y power equals x. Does that make sense, my friends? Now, there are two super important properties that you must learn today and keep with you for the rest of this chapter. But they're really easy. If I have base b raised to the log of base b times a, this base cancels out the log base b, and I'm left with an a. If, vice versa, if I have log base b of b to the a power, the log base b cancels out the b, and I'm left with just a. What the hell is he talking about? If I tell you 5 to the log base 5 times 32, and I say equals what? This base of 5 cancels out this log of base 5, and I'm left with an answer of 32. If I have log of 10 to the third power, what is the base of log when it's invisible? If I have the log base 10 and my answer is the same as the base, they cancel, and my answer will be 3. So when my base and my base of the log are equal, they cancel, and you are left with the value that is being multiplied. In other words, the answer. So, sorry about that, guys. Little interruption. Okay. So, again, let me try this again without the interruption. What have I told you? Log base 3 times 3 to the 5th power. What does that equal? This log base 3 cancels out the answer of 3, and you're left with 5. Vice versa. 4 to the log base 4 of 12. This base of 4 cancels out with this log base 4, and I'm left with 12. Yes, sir. Yeah, this is raised to the power of 5. This 3 and that 3 cancel, the 5 drops down. In this case, log base 4 to the 12th power is the exponent. This base cancels out with the log base 4, the exponent drops down. Thank you. Now, the good news. Some things you can do on your calculator, and you're going to have to. Please note that your key in your calculator that says log, that's when you use only when the base is 10. Period. If the base is not 10, you're out of luck. You cannot use your calculator. Okay? Not yet. I'll teach you how to do it. If you have a base of e, you must use ln. There's no choice, unfortunately. You must use ln. Okay? Now, let's start working with some of this stuff. Whoa. Okay. Let's first start by rewriting each exponential expression as an equivalent expression using a logarithm. Okay. What's the base here? What's the exponent here? So as a log base 5, what's the answer? B equals 4. What? 5 to the 4th power equals B. Does that make sense, guys? 1.9c equals 12. What's the base? If this helps you, you could do this. The base is 1.9. What's the exponent? No. Oh, yeah, the exponent, sorry, C. And what's my answer? 12. So, log base B of the answer equals my exponent C. Sir? What do you mean 12 out of power? No, this is log base 1.9. This is the answer, 12. It's not raised to a power. W to the 1.2 equals 7. How would I write this? As a log. Log base W of the answer equals the exponent. Beautiful. Beautiful. Well done. That makes sense. Be honest. Did you think that would be a lot harder than what it is? Right? I always feared logs until I learned them. I went, oh, this is easy. Okay, now, don't stress. Rewrite this logarithmic expression as an equivalent expression involving exponents. So remember, this is the base, right? Base to the y power equals the answer of 81. Now, I'm going a little ahead of myself, but using the skill that we already learned about exponential equations, how can I solve for y here? Very good. This is 3 to the y equals 3 to the 4th power, right? Same basis. What happens when you have the same basis? And then y equals 4. This, I went further. This would have been evaluate. All I wanted was this. I just got a little carried away. Just so you can make a connection, so you can see that what we're learning is not in vain, my friends. What we're learning is building and building and building. Okay, how about here, my brothers? How would I write this as an exponential equation for us? An exponential equation, yeah. A to the negative 3 equals 1 over 27. Very good. Would I be able to do this exponentially? No, not too much. Why? Because I don't have a base. Right? We'd have to do something different with this, which we'll learn very soon. All right, next, C. How would I write that as an exponential? 4 to the 2nd power equals x. Very good. Beautiful. Now comes the fun part. Let's evaluate the exact value of each. Now, unfortunately, you see this and you're like, wait a second. It's not a base 10, Mr. Morrow. I can't use my calculator? You can, but I'm not going to show you how yet. I'm going to first tell you how to do it the right way, by hand. When you have something like this, doesn't this equal y, the exponent? So isn't this 2 to the y power equals 32? So let's go. 32, how can I rewrite that as a base of 2? 2 to the 5th. When I have the same bases, they cancel. So y equals 5. So the answer to this is 5. Does that make sense, my brothers? How about this bad boy? Go ahead and set it equal to y. This is going to be 5 to the y power equals 25. In this case, you should know already y is going to be 2. That's the answer. For this one, how do I set this up for C? Thank you, my brother. Make it equal to y. You're awesome. 4 to the y equals 1/16. Now, this one's a little tougher. What does 16 turn into if we're talking about bases of 4? Very good, Papa. This is 4y equals 4 to the negative 2. Beautiful job. Remember, guys, this is 1 over 4 squared. So my boy brought it up. That is, you really made me proud. Good job, my brother. The bases cancel. Y equals negative 2. Are you guys with me here? Okay. Now, sometimes I have to evaluate, and then I have to solve after I evaluate. I want to find f of 2 when f of x equals the log base 2 of x. What am I replacing every x with? Okay. F of x is just y, right? So this is going to equal log base 2 of 2. Wait a second. What happens when I go log base 2 times the answer, which is the same as the base? They cancel, so y equals 1. Let me show you why that works so beautifully. I have this. Isn't this in essence 2 to the y power equals 2? Right? So what does y have to be? 1. But even easier than that, when I have the log of a certain base next to the value that is equal to that base, those guys go bye-bye, and I'm just left with the leftovers. Does that make sense, my friends? Yes, sir. Thank you. The f of x? No, because we're dealing with logs right now. So we're not going to have f of x equals 3x squared plus 5x minus 9. That's a polynomial. These are logs. So I can have complicated logs, but not that type. Okay? Thank you, my brother. May I continue, gentlemen? Okay, let's go. Graphing. No. Graphing's easy. And it's just like yesterday, okay? Just like all functions, logarithmic functions can be reflected, stretched, compressed, shifted to the left or the right, or shifted up or down. So let's see how it works. Okay, and this is wrong. It's not exponential parent function. The logarithmic parent function is y equals log base b of x. The complete Wrong. It's not exponential function. The complete logarithmic function, sorry about that, is y equals a. Remember, that's going to tell me if it's up or down. Log base b of x minus h. Remember, the h tells you if it's a left or right shift. Plus k. Remember that the k shifts it up or down. Everything that we've learned is the same. If a is greater than 1, it's a stretch. If a is between 0 and 1, it's a compression. A reflection, that means that it goes from going up to going down, occurs when a is negative. Okay? B is the base, we know that. H shifts the graph left if it's positive, right if it's negative, and determines the vertical asymptote and domain. You guys remember what domain is. Remember what a vertical asymptote is? That's that little wall, right? That little dashed line that you can't cross, right? Okay. And the k shifts the graph up or down. A couple more things, then I'll show you the graph. The domain of a logarithmic function is found by setting the x minus h not equal to 0. The range is always all real numbers. Remember how we talked about that exponentials and logarithmics are inverses? Well, if you think about the exponential, it's reversed. Okay? The domain is all real numbers. Very good. And the range, it depends. So these are inverses. Now, what does a log look like? That's a log. That is a log, my friends. That is a positive log. Okay? What does a negative log look like? It's like this. That would be a negative log. How on earth do you get this function? How do you get the graph? Let's say I tell you real quick, f of x equals log, whatever, base 3 of x. Okay, you ready? I'm going to blow you away. First, turn this into an exponential. This is 3 to the y power equals x. Now make a table. But since the logarithm is an inverse of a exponential, is x independent anymore? No. Y is independent. So choose for y. Choose values of y. Remember, I have to have values greater than h. Okay? In this case, h is 0. Right? I have no value next to that x. So h is 0. So that means it's my y-axis. So I have to choose values greater than that. So let's choose when y is 1, when y is 2, and when y is 3. How about that? When y is 1, 3 to the first power is 3. When y is 2, 3 squared is 9. When y is 3, 3 cubed is 27. So let's just make a little graph here. I'm going to estimate the numbers. So here's 1. Let's just say here's 2, and here's 3. For my x's, let's say that's 3. Let's just say that's 9. And just for giggles, let's just say that's 27. So this would be 3, 1. Okay. 9, 2. 9, 2. And this would be 327. So be like here. Or 27, 3 rather. So this would go like this. And that is my graph. You're going to get really close to the y-axis, but you're never going to hit it. Yes, sir, my brother. Yes, sir, my brother. It can cross it into the other quadrants if I have a shift. Okay? That's why, if you notice, my domain or my vertical asymptote is x minus h cannot equal 0. Yes, sir. Yes. Yes. The question was, what happens if I have an h number? Look, let's say I tell you y equals log base 2 of x minus 2. First thing you want to do, I'm going to set x minus 2 not equal to 0. So x cannot equal 2. So what does that mean? That means that 2 is now my asymptote. That is the line that I cannot cross. You with me here, guys? Now, let's set this up into an exponential function. This is 2 to the y equals x minus 2. Make a table, guys. But remember, only the y now is the independent. So let's do it when y is 1. When y is 1. When y is 1, I got 2, right? I add 2 to both sides, so x would equal 4. You with me here, guys? When y is 2, I got 2 squared is 4. Add the 2, that's 6. When y is 3, 2 cubed is 8 plus 2 is 10. So 3, 4, And then we got all the way to 10. 5, 6, 7, 8, 9, 10. So I've got 4, 1. 1, 2, 3, 4, 1. Then I've got 6, 2. I messed up, didn't I? That's 3. 4, 1. Then 6, 2. 1, 2, 3, 4, 5, 6, 1, 2. Then 10, 3. 10, 1, 2, 3. And this will go like this. Real close to that asymptote, but never crossing it. Yes, sir. I'm sorry? Because I followed the equation. When y is 2, 2 squared equals x minus 2. That's 4 equals x minus 2. Add 2 to both sides. 6 equals x when y is 2. Thank you, my friend. Thank you very much. Does that make sense, guys? Okay. For example, let's graph this. Make this a y. It's log base 2 of x. Now let's make it an exponential equation. 2 to the y equals x. Now let's make a nice table. When y, it can't be 0, remember that. The domain of a logarithm function is always greater than 0, or x minus h is not equal to 0. But there's no h here, so I cannot use 0. My y-axis is my asymptote here when there's nothing attached to the x. You guys with me there, my brothers? Okay, this is heavy stuff, so I want to make sure you got this. I want to do a good job. You with me, my brothers? Thank you. So, when y is 1, 2 to the first power is 2. Done. When y is 2, 2 squared is 4. Done. When y is 3, that's 2 cubed, so that's 8. Done. What's my asymptote? My y-axis. Why? Because there was a 0 there. So I got 2, 1, 4, 2, and 8, 3. So, real close to getting to the asymptote, but never getting there. Does that make sense? Now, we're not going to get crazy into graphing logs. For this course, I need to introduce it. I need you to know what's going on. You'll get into crazy log functions in pre-calc. But when you get to this, you can say, oh, that's right, I remember Moral talked to us about this already. And you have it in your brain. Now, sometimes they're going to ask you just to find the domain. Remember, finding the domain is the same thing as finding the vertical asymptote. So all you do is take the x plus h, or x minus h, set it not equal to 0. So x plus 1 cannot equal 0, so x cannot equal 1. That's my domain. So my domain is negative infinity. I mean negative 1, I'm sorry. Negative infinity to negative 1. Union negative 1 to positive infinity. And just for giggles, if I wanted to graph this, my brothers, check it out. My vertical asymptote, negative 1. Let's set this up into an equation. This is 3 to the y power equals x plus 1. Let's make a table. When y is, in this case, can y be 0? No, actually, y can be anything it wants. So yeah, y can be 0 in this case. And I could go 1, and let's go 2. When y is 0, this is 1, right? 3 to the 0 is 1. Subtract 1 to both sides, 0, 0. When y is 1, 3 to the first power is 1, is 3. Minus 1 is 2. When y is 2, 3 squared is 9. 9 minus 1 is 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2. And this is my graph. I'm telling you right now, we're not going to have to graph this type. We're not. But I like to teach you more than what you need. Sir? Actually, yeah, no. Now that you said that to me, I had a little bit of a, yeah, let's go ahead and say it, a brain fart. Didn't I just tell you guys the domain has to be greater than 0, blah, blah, blah. Apparently, my blah, 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 I didn't listen. How on earth can it be negative infinity and negative 1? Sometimes I'm stupid. Thank you for helping me out there, brother. The domain here is just negative 1 to infinity. I'm an idiot. Sometimes I'm stupid. Thank you, my brother. God bless you. Yeah. Before I had said that it was from negative infinity to negative 1, right? So that means that this part, that's impossible. Has to be greater than 0 or greater than the asymptote. I can never go to the left of the asymptote. So I'm a fool. Thank you, sir. God bless you. Okay. How about this bad boy for B? What's my domain? I go x minus 5 not equal to 0. So x cannot equal 5. So that means that here at the 5, there's an asymptote. So it's got to be greater than 5. So 5 to positive infinity. Wow, thank you so much for saying that. Really proud of you. Does that make sense, guys? We've done a lot today. We still got a little bit more. You hang in there with me? All right, you guys are the best. I think this is the last page, right? Okay, last page. Easy, easy. Don't stress. Because look what I have there, guys. Look what I got for you. Yay! Okay, let me explain. As long as you have an ln or a log, you can use the calculator. As long as you have an ln and a log, you can use the calculator. Remember, ln is log base e. That's why they call it ln. It's a natural log. Log by itself is log base 10. That's called a common log. Okay? So, my friends, you tell me. ln of 20, what do you do? Usually, look at your calculator. It may just be the regular button, or you may have to shift. Okay? So in mine, I have to do nothing. I have an ln key. So I go ln 20. The answer you should get, guys, is 2.9957. Let's go out to 4 places to make sure that we're accurate. Does everyone get that? If you don't, tell me so I can come to you. It's just ln times 20. Literally plug in what's there on the board. Literally. Can you do it if I have it like this? No. There's another way to do it. It's called a change of base formula, but I'll show that to you tomorrow. I promise. I promise. Log of 30. Hit log. Plug in 30. And it should equal 1.4771. ln of 0.5. ln 0.5. That should equal on your calculator negative 0.6931. Right? So this is Mickey Mouse. You can use the calculator for stuff like this. You can. Calculator's not going to be super awesome all the time for this chapter, but when it is, oh, it's sweet. Okay? Now, last thing. How do we solve equations? This is just the preliminary, okay? There are more techniques, but I have to teach you the properties of log tomorrow. And then Friday, we'll wrap this sucker up, okay? And then we'll have review on Monday. But for today, just to start easing you into this, pay attention. Yes, sir, my brother. Test is going to be the whole chapter. 11.1 to 11.5. It's only five sections. Okay. Now, can't I write this as 2, good man, to the 4th power equals 3x plus 4? Guess what, guys? You took a super complicated thing and you made it darn right easy. Now, what's 2 to the 4th power? 16 equals 3x plus 4. Now, this should be absolute Mickey Mouse for you guys. That's why I'm not even telling you what I'm doing. Because you know what I'm doing. Done. Does that make sense? Talk to me, my brother. Okay, I said, okay, hold on. Didn't we say that log base b of an answer equals y? Doesn't that turn into b to the y power equals x? Isn't that my base bubble? Isn't that my exponent? So 2 to the 4th power equals the answer, 3x plus 4. Thank you so much for your honesty. Does that make sense here, guys? Okay. Now. B, we'll do it in green. What's the base here? Log x 25. So this is x squared equals 25. Square root x equals plus or minus 5. However, no. No. You can't have the domain be negative. But in this, no, you're fine. Plus or minus 5. Wait a second. No, yeah. It would just be plus 5. Because the domain has to be negative. I mean, positive. ln of x equals negative 2. What is the base of ln? E. No, guys. When I go log, it's base 10. ln, base e. So this is e to the negative 2 equals x. Go ahead, guys. Use your calculators. So you're going to have, in my case, second function. My e is above the ln. It will always be above the ln for you guys. So e to the negative 2, and that equals 0.1353. Please let me know if you got that. It's really important. Yes, sir. You got it? Does that make sense? All right, guys. Last thing. I know you're dying. I'll make it quick, but I got to show you how this works. And this, I actually really enjoyed this example because it's very useful. It's real life. The loudness L, measured in decibels of a sound of intensity X, measured in watts per square meter. This is legit. This is how we get decibels, how loud something is. For a normal conversation, okay, if a normal conversation has an intensity of 10 to the negative 6 watt per square meter, how many decibels is a normal conversation? Well, plug in the X which they gave you. So this is going to be the loudness, or the number of decibels, is going to equal 10 times the log of 10 to the negative 6 over 10 to the negative 12. Are you guys with me so far? You promise? Okay. Turn this bad boy into a y. This equals 10 log of, guys, what's 10 to the negative 6 divided by 10 to the negative 12? I love this class. 10 to the 6. You guys rule. Now, pay attention and let me know if I lose you. What's the base of this log? So isn't this 10 to the y equals 10 to the 6th, correct? Come again? Because my base is 10. Hold on for 1 second. Hold on. Okay, guys, yeah. Little mistake. Let's go back here real quick. So this is log 10 to the x. Okay, 10 to the 6th. Now, I have y equals, like my boy said, what is log base 10 times 10? What happens with that? It cancels. So I have 10 times, I bring down the 6, 60 decibels. Well, think about it. You had a log base 10 times 10. So those cancel. This 6 gets multiplied to the 10. I heard an oh, so that means it's good. Guys, homework is valid. Thank you so much. You're the best. Have a great day. Hope you learned a lot.